I have in previous video discussed dedicant kite and dedicant cards. So today I discuss our relation of equality and order in cards. Relation of equality and order in cards. So before starting this topic, I to all of you to subscribe this channel. If you have not subscribed, like then like and share with your friends. And if you have further suggestion, comment. So let's start. How we define equality of cards. If you know clearly the definition of cards, then you can understand this. So watch my previous videos, then you can easily understand equality of cards. So if we consider two cards, so if we consider two cards, consider two cards, cards. First x1, x2, and the second is y1, y2, y1 and y2. These cards are of real numbers. So the two cards are said to be equal. They are said to be equal. They are said to be equal. Equal if every member of x1, each member of x1 is member of y1 and vice versa. So in another term you can say that x1 is equal to y1, or in another term x1 is equal to y1. If this happens, this implies that also that x2 also equal to y2. So every member of x2 must be equal to y2. Then we say that these two cards are equal. So then it is denoted by, you can write that two cards are equal. Means equal to y1, y2. Now this is the difference of equality of two cards. Now let's go in another order relation in cards. Order relation in cards. So this can be less than type or uh, greater than type. Order relation we have defined. I have defined the equality of cards. Now order relation in cards. So how I define this? If we again consider two cards, x1, x2, and y1, y2, and y1, y2, then if it happens that each member of x1 lies in y1, but the reverse is not true. But the reverse is not true. Then it implies that this statement implies that x1 is the proper subset of y1. It implies that x1 is the proper subset of y1. Then we have order relation that and this also implies that y2 is a proper subset of x2. If we uh, if we uh, try to understand this is very simple to understand. If x1 is a proper subset of y1, then y2 will be the proper subset of x2. Then we can write that and write that the part x1 x2 is less than y1 or this can be another term can be represented by in this way y1 y2 this part is greater than x1 x2. So this is the order relation of between two curves. Now we'll go trichotomy law of curves. This is important one. Trigonometric law of curves. Trichotomy 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 law of curves. So between any two cards, this law holds. If we again consider two cards x1, x2, and y1, y2, then trigonometry law said that this law tells us among these two, among any two cards, there must be a relation of less than type or greater than type or equality. So, or equality. So, among the three relation, one relation must exist between any two cards. This is the teachability law. So, if the cards are of real numbers, then it may be that x1 this card x1 x2 is less than y1 y2 or x1 x2 is greater than y1 y2 or x1 x2 is equal to y1 y2. So how you can compare? I have already said if x1 is the proper subset of y1, then x1 x2 less than y1 y2. If y1 is the proper subset of x1, then y1 y2 is less than x1 x2. And if x1 has all the members in y1, y1 has all the members in x1, then equality holds between the two cards. This is the teachability law. Now we'll go transitivity of order relation. So this is one important one, that cards flow transitivity law. Transitivity law. We have a order relation of transitivity law. Transitivity law. This is among three cards. Always hold between three cards. So you consider three cards now. Take x1, x2, y1, y2, and z1, z2. So all the order relation follows transitivity rule. If we consider less than type, then it can be very easily established that if x1 is the proper subset of y1 and y1 is the proper subset of z1, so x1 must be proper subset of z1. So less than follows transitivity law. Less than order follows this law. And now you can also verify the greater than type relation. This also follows the transitivity law. If x1 is the superset of y1 and y1 is the superset of z1, then x1 must be a superset of z1. So greater than also follows the transitivity law. The transitivity law. And if you consider the equality relation, then if x1 has all the members in y1 and y1 has all the members in x1, also y1 has all the members in z1, z1 has all the members in y1, then also you can say from these two relations that x1 has all the members in z1, z1 has all the members in x1. So equality also follows this law. So all the relation follows transitivity law in cards. Important one. Now we define a new one, that this is the zero part. Zero part. How we define zero part? Zero part is denoted by. It is denoted by in this way, 01, 02. So here 01 is the set of all numbers less than equal to 0. All rational numbers. All rational numbers. Rational number does not form a card. Rational numbers forms a card. All rational numbers less than equal to 0. and O2 follows that all resonance greater than 0. So now this division fulfills all the requirement of a card or dedicated card. So one O2 forms a card. So this is called zero card. Just divided by all the resonance in real numbers divided by 0. And this is called zero card. Now we'll define what is positive cut and negative cut. Positive cut, positive and negative. What is positive negative cut? If it happens that all the resonance less than 0, less than equal to 0, is pointed in a member in a set x1, that x the class lower class O1 is the subset of x1, and also x1 and x2 forming a part. If it happens, then we will say that this is x1, x2 is for positive part, or there is a order relation better than 0 1 1 would do, you can say. So now this is called positive part, and it is negative if x1 is upper subset of O1. Now we have a relation x1 x2 less than O1 O2. So it is better to say O1 O2, not G1 G2, alphabetically O1 O2. So if you will find out that x1 is a proper subset of the lower class O1, then we will say this is a negative part, and if it is greater than the zero part, then it will be a positive. These are the definitions necessary. I continue my class on the parts, so keep watching this video, and also to get all these videos when I download. When I download, you will get the notification. Subscribe this channel to get the notifications, and continue watch my videos in my channel. Thanks for watching.